All right, properties. What kind of properties do you remember besides the distributive property? What kind of property? Commutative? Distributive? Starts with an A.
Don't give it to us.
Associative?
Associative. Some people might be on the both pages.
Identity?
And identities, very good. Those are the properties, okay? Those properties, associative, commutative, and identities, only work for what operations? Multiplication or addition, okay? Those properties only work for multiplication or addition, which is why we change everything to addition or multiplication, right? If I have a subtraction, I change it to an addition problem, right? Keep, change, change. If I have multiplication of fractions, I change, division of fractions, I change it to a multiplication problem. Keep, change, flip, okay? That's because then I can use these properties, all right? So normally this would be a whole lesson. I'm just going to review real quick here. The commutative property means the order that you do additions or multiplications doesn't matter, right? You can switch. 3 times 7 is the same as 7 times 3. A times B is the same as B times A. And the same thing with adding, okay? Commuted, it's called commutative because a commuter is a person who drives to work and then drives back home, right? So their commute is the same thing except in a different direction, okay? That commutative property. Associative property means that you can group. You have more than 2 things that you're multiplying or adding. You can group them however you want. You can change the order of them and you can group them and do the first 2 first. You can do the first one and the last one. You can do the last 2 first and then, okay? You can associate, put them together, whichever groups you want. Okay, that's the associative and commutative properties. The identities, okay, the identities are like so obvious, right? That you don't even think of them as rules, really. When you add 0 to anything, it doesn't change the number. That's the additive identity. Adding 0 doesn't change anything. The multiplicative identity is multiplying anything by 1 doesn't change the number. Multiplying by 1 doesn't change anything. And the multiplicative property of 0 says if you multiply anything by 0, you get 0. 0 of anything equals 0. All right? So, okay, the distributive property is what you use to simplify expressions that have parentheses in them. Is demonstrating that this expression with parentheses is equal to this expression with no parentheses. Okay? And this is what the distributive property is going to do for us. It's going to go from here to here. We're going to just take a look at some distributive property stuff. Okay? There's a good video here in Math Antics talking about the distributive property. Now, when you're doing all numbers, okay, when you're doing all numbers, sometimes the distributive property is easier and sometimes it's not. Sometimes it's easier to use the order of operations when it's all numbers in your problem. How would you do 3 times 4 plus 6 using the order of operations? What is the first step if you're using the order of operations? Do what's in the parentheses, right? So I would add 4 plus 6 and get 10, and then 3 times 10 is 30. That's pretty simple. How would I do this with the distributive property? The distributive property, I'm going to multiply each thing inside the parentheses by the number that's outside the parentheses. So that gives me 3 times 4 plus 3 times 6. Distributing the 3 multiplication to everything inside the parentheses, which is 12 plus 18, which is 30. Which one of these is easier? The order of operations is easier in this problem, okay? The order of operations is easier in this problem, all right? Well, what about this problem? 4 times 26. Well, I can break this problem up and make this a distributive property problem. right? 26 is the same as 20 plus 6. So I could split this up to make this 4 times 20 plus 4 times 6, which really is the distributive property, like that. Okay, this is how I do 4 times 26 in my head. I don't do 4 times 6 is 24, carry the 2, 4 times 2 is 8, and 2 is 10, 104.
How do you do that?
That's not how I do it. I do 4 times 20 is 80, plus 4 times 6, 24, 80 plus 24 is 104. That's how I do this in my head using the distributive property. That's all we want to show you here is that you can do that. It's a useful way to do big arithmetic, especially 1 digit times more than 1 digit, to do this using the distributive property. You don't write it out typically, you could, right? And if you have a calculator, then you do 5 times 132 in your calculator. Okay, but if you don't have a calculator, how do you do 5 times 132 with the distributive property? 5 times 100, 5 times 30, and 5 times 2. Split or expand this number into its places. And then, much easier now, that's 500. 5 times 30 is 150, and 5 times 2 is 10. 500 plus 150 plus 10, 660. You can do that in your head, this kind of multiplication, without a calculator by using the distributive property. Okay? So, yes, you should be able to do that, and you may see some problems like these. I'm going to skip the rest of these for now. Okay? But that's the process. The distributive property is more useful, really required, when you have algebraic expressions, okay, where you can't use the order of operations with A's and B's, okay? So here, this example is 2 times x plus 2. That's the problem that they're working on in this problem in the book. 2 times x plus 2. And you cannot add x plus 2 together to get, who knows what that is, because I don't know what x is. So I can't add these together in the order of operations. I have to use the distributive property to eliminate these parentheses and simplify this expression. Okay? So algebra tiles are little counters that you use to represent variables and numbers, right? We use sticks to represent variable x, and we use squares, little square tiles to represent the numbers. So this is x plus 2 to put out on a mat if you were going to do these by hand. Definitely not doing that in COVID times. Okay? Well, there's 2 of these. There's an x plus 2 and another x plus 2. 2 times x plus 2 is this mat right here. The distributive property lets me combine together the things that are the same here. So I have 2 x's, right? Put them together, and 4 1s. So it's 2x plus 4. That's the simplified expression. These expressions are equivalent, just like we talked about with the pens and the notebooks, right? These 2 expressions are equal. No matter what you put in for x, you'll get the same answer in both of these versions of this expression. They are equivalent expressions. They equal the same thing. No matter what x is, you'll get the same number, okay? All right, so I like to use the distributive property. I like to call it the rainbow method. It's helpful for some people to remember what the distributive property is. Why I wore this tie today. This is my closest tie to a rainbow tie that I have.
What kind of tie is it?
It's a Jerry Garcia tie, one of my favorite brands of ties. But it's just, a rainbow of colors. I don't have a rainbow tie. Otherwise, I would wear it because today's rainbow method day. All right. Why do I call it the rainbow method? Okay, because you can draw a little rainbow that connects the multiplication number in the front with everything on the inside. It looks like a little rainbow. Okay, so this is when and I'll say this all the time. Oh, got distributive property, so we're going to do a rainbow. okay? And write these little curvy lines to help you remember to multiply everything inside the parentheses by the number in the front. Okay, and when we multiply a variable term like this, right, 3y's, you just multiply the coefficient, multiply the number in front. So 2 times x gives me 2 x's, and 2 times 3y gives me 6 y's. Okay. So the rainbow tells you the multiplications. You can write them out separately like this. This is an optional step eventually, right? You can just do these multiplications in your head and write the answer. 2 times 3y is 6y. Multiplying the coefficient by that number in the front. Okay? So this is the answer. This is the simplified expression. You're like, that's not an answer, Mr. Riley, 2x plus 6y. When you're told to simplify an expression using the distributive property, that means no parentheses. You have to eliminate the parentheses by doing the rainbow. This is your answer. That's the simplified expression, 2x plus 6y. Someday later on, we'll use real world problems where x and y represent things, but not right away. That gets much more difficult, okay? All right, so sometimes there's negative numbers because we're in 7th grade, so we do positive and negative numbers. So because you've already done the distributive property, haven't you learned this last year? Or maybe even before that. Yes? Maybe, yeah. Could be right when you learn multiplication.
No,
Okay, so -4 times 5 and -4 times 2y are the two parts of the rainbow for this problem. What's -4 times 5?
-20.
-20. And what's -4 times 2y? -8y. Okay? -20 plus -8y. Y is what?
Why is that the answer?
That's the answer. Not, it could be kind of cleaned up a little bit.
A wee bit.
Okay, because plus -8y, I don't really like the way that looks, so I might change. Plus a negative is the same as, adding a negative is the same as subtracting. So I could change this to -20 minus 8y. Be the same thing, right? Plus -8y is the same as minus 8y. Yeah. You know what? I'm reminded now as I'm teaching this that I don't like the order the book does this, and I should have gone the other way around.
Wait,
But
what now?
It's too late.
Wait, what is that?
It's too late.
What's that?
There's another lesson about like terms that I should do before this one, but the book does them in this order. I don't know why. Oh well, we'll move on.
Oh, Mr. Riley.
Okay, be careful with subtractions. Now, subtractions inside the parentheses means you can just do subtraction of your two multiplications when you do the distributive property. But if there's a minus in the front, this can be really ugly, okay? And easy to make mistakes. So I'm going to tell you to change subtractions to adding the opposite. Change subtractions to plus negative. That way everything is addition and we don't have to worry about that. And it also helps you because if there's a negative here times a negative here, that answer is going to be negative times negative is positive. Bad thing happens to a bad person. So this will help us keep straight with not making mistakes with positive and negative numbers. -3 times 2x and -3 times -7. That's my rainbow. -3 times 2x and -3 times -7. So -3 times 2x, you multiply these numbers together and just put an x in there. That's -6x. And -3 times -7 is positive 21. So it's -6x plus 21. And that's my answer. These don't look like answers. I get that. Like, that's not an answer, Mr. Wright. Yes, it is. That's answering the The task that you are told is to simplify the expression.
Ow, but why?
Simplify the expression.
Why are there letters in the answer?
It's algebra.
No, I don't know.
All right. So the book has 3 examples like the ones that I just did on page 377. Distributing. Okay, and the first couple of these don't have negative numbers in them, so that's kind of helpful. So one thing I can point at, so this one is 4 times x plus 4 times 7, right? You can write in your little rainbow there. This one, 6 times p minus 6 times 5. Since there's only this one subtraction here, you could do this like this and get 6p minus 30 and leave the subtraction in there. Okay, there's no negative number in the front. There's no negative numbers. This isn't so bad to do. But to be safe, always change your subtractions to plus a negative like they did in the book here. Okay, then you get positive times negative is negative 30. And then you change plus a negative back to subtraction because that's what subtraction is, adding the opposite. Really important when you have a negative in the front. Now, let me just point right here that this x, there's like a little 1 in front of that x when you multiply. So it's like negative 2 times 1. We'll talk more about that in the next lesson. All right, so after examples, that means it must be time for some more examples. Yikes. All right, this one has variables in both of the terms inside the parentheses. That doesn't really change anything except you have x's and y's in your answer.
What?
And this one, oh no, fractions. I thought we were done with fractions. Well, not really. We'll just put them in everywhere now. Right? 1/3 times x and 1/3 times negative 6. 1/3 times x is 1/3 x. 1/3 times negative 6. Remember to multiply fractions, you have to have fractions. Okay? You can't just think about what 1/3 times 6 is in your head. And so then you can cross reduce here. They're both divisible by 3, and you get negative 2. That's where that comes from. So 1/3 x plus negative 2 or 1/3 x minus 2. You can write your answer either way like this.